Okay, in this part, we will continue discussing decision making under risk and we will do Bayes' theorem in this part. What is Bayes' theorem? It is a theorem describing how the conditional probability of each of a set of possible causes for a given observed outcome can be computed from knowledge of the probability of each cause and the conditional probability of the outcome of each cause. We actually know the conditional probability of which are called prior probabilities, which is known, and we can compute the conditional probability which is called posterior probability. So Bayes' theorem relates the conditional and marginal probabilities of stochastic events A and B. For example, it is given that probability of AB is equal to probability of B, so that A has happened into probability of A into probability of B. Each term in Bayes' theorem has a conventional name. Probability of A basically is the prior probability or marginal probability of A. It is prior in the sense that it does not take into account any information about B. So it is independent probability of mutually exclusive event. If A is mutually exclusive, then probability of A oblique B is the conditional probability of A because it depends on B. It is also called the posterior probability because it is derived from or depends upon the specific value of B. Then probability of B oblique A again is the conditional probability of B given A. And probability of B basically again it is independent probability. It is the prior or marginal probability of B and acts as the normalizing constant. So this is basically the method of Bayes' theorem. These are the steps. First of all, we know the prior probabilities. With the help of these prior probabilities, we make our data, we get informations, and then we apply Bayes' theorem on the data and we get posterior probabilities out of it. These are the simple steps of Bayes' theorem. Okay, solving an example. This is the example where market survey reliability in predicting actual states of nature are there. If we are taking a survey from the market, then it may be a positive survey or a negative survey. Positive means predicts favorable market for product, and negative survey means it predicts unfavorable market of the product. But actually, what are the actual conditions of market? These are there. Market favorable, it has 50% probability, and market unfavorable, it has 50% again probability. In the table, you can see that probability of positive survey if the favorable market is there, it is 0.7. It is the conditional probability. Again, a conditional probability of survey positive. If the market is unfavorable, then we have it is the value of 0.2. For probability of survey negative, and it depends on prior probability of favorable market, it is 0.3, and probability of survey negative if the unfavorable market, it is 0.8. These are conditional probabilities. We can solve it with the first step. We can write it on the tree diagram where we have favorable market and unfavorable market known to us 50% of chance for both. If market is favorable, we have two choices that positive survey may be there or negative survey. These are two possibilities. So if positive survey is there, then it is 0.7. If negative survey is there, 0.3. These are conditional probabilities which depends on favorable market. Similarly, conditional probabilities for positive and negative surveys depending on unfavorable market are 0.2 and 0.8 respectively. These are called prior, this diagram is called prior probability tree. We can convert this diagram into posterior probability where we have to know the favorable markets if the favorable market or unfavorable market depending on the positive or negative surveys. So these are posterior probabilities, they are not known. How can we calculate it? With the help of Bayes theorem, we can know that probability of positive survey is equal to probability of positive survey depending on favorable market multiplied by probability of favorable market plus probability of positive survey depending on unfavorable market multiplied by a probability of unfavorable market. So these all things are known, all probability is known. We can calculate probability of positive survey, it is equal to 0.45, and probability of negative survey can be calculated in a similar fashion, which is 0.55. So these are marginal probabilities we have calculated from the data, and we are actually applying the Bayes theorem over here. So these two probabilities 0.45 and 0.55 can be marked to the positive survey and the negative survey on the tree diagram. So these are basically joint probabilities now, because they are producing the joint effect of the previous data. Okay, next, coming to the next one, when we have to calculate the posterior probabilities, where we have to calculate probability of favorable market if positive survey is there and probability of favorable market if negative survey is there. It is calculated with the help of, again, Bayes theorem. You can see the formula, and we have just given the values which we know. It is equal to 0.78. We have now calculated positive survey 0.45 and negative survey as 0.55. We can use those values in it. We have found that probability of favorable market when the positive survey is there, it is 0.78, and probability of favorable market when negative survey is there, it is 0.27. Similarly, posterior probabilities for unfavorable markets can also be calculated on the similar fashion, and we have found that probability of unfavorable market for positive survey is 0.22 and probability of unfavorable market depending on negative survey is 0.73. These four probabilities again can be mapped onto the figure. So you see that we have actually done our, we have used Bayes theorem with the help of this, and we have found, okay, this Bayes theorem is tricky to use. You have seen it, but very simple method of using Bayes theorem is there also. You can use the Bayes theorem with the help of tables only. You can mark the values in the tables, and you don't have to write the lengthy formulas. With the help of tabular method, you see that we can find if positive survey is there and when negative survey is there, and we can have prior probabilities or favorable and unfavorable market. You know that probability of favorable and unfavorable market independently is 50% for both, and the conditional probabilities for both are given 0.7 and 0.2, 0.3 and 0.8. Okay, you can find that the sum of favorable market should be 1 and unfavorable market should be 1. The next step, these are prior probabilities. The next step is to find the joint probabilities table. How to find the joint probability table? You just have to write it that you have to multiply it with the independent probabilities of favorable market and unfavorable market. If we multiply all the values with those, we can find that favorable market and unfavorable market, if positive and negative surveys are there, it becomes 0.35 and 0.1, 0.15 and 0.4. Actually, we are multiplying, let's say, 0.7 with 0.5, then 0.2 with 0.5, 0.3 with 0.5 and 0.8 with 0.5, and we have found the values. So these are joint probabilities, and this table is joint probability table. From this table, we can move ahead and we can find the joint probability table again, where this is the marginal probability table. We can just add both the values for positive survey and for the negative survey, and we can find the marginal probability for positive survey only independent is 0.45 and for negative survey it is 0.55. And again the sum should be 1, otherwise you are doing wrong. Next step is finding the posterior probabilities. You just has to divide the joint probabilities with marginal probabilities of each. For example, 0.35 divided by 0.45, it is 0.78. Again, 0.1 divided by 0.45, 0.15 divided by 0.55 and 0.4 divided by 0.55. So the marginal probability, the posterior probabilities have been calculated. So this is a simple method of finding probabilities with the help of Bayes theorem. So again the same problem, another one where we can see that the first table shows the probabilities of, for example, 0.7 is the probability of positive survey when favorable market is there, and 0.8 is the probability of negative survey when unfavorable markets are there, and others can also be marked. Similarly, 0.15 is the probability of negative survey when favorable market is there multiplied by probability of favorable market. Similarly, the marginal probability of 0.55 can be calculated with the help of this formula, which we did it in the previous slide, and where we can find the value of 0.55. Similarly, from there we can find the posterior probabilities. So, what is the application of Bayes theorem in the production system? For example, let's say a small manufacturing unit has 2 machines, old and new. Over last 1 week, 200,000 parts were produced. By old machine produced 80,000 parts. 200,000 parts made, and out of those, old machines produced 80,000 parts. Inspection data revealed that 12,000 parts produced by old machine were non-conforming. Old machine produced 12,000 parts, means out of 80,000 parts they produced 12,000 were non-conforming. A similar inspection report was cited as saying that even new machines produced 9600 non-conforming parts. It means out of 200,000 parts, 80,000 parts were produced by old machines and 1,20,000 parts were produced by new machines. And out of those 1,20,000 parts, the non-conforming parts were 9,600. So how many faulty parts are expected to be produced for next week? So production orders stand at 400,000 parts for next week. So this week it was 200,000 and next week it is 400,000. So what is our objective? We have to find that how many faulty parts are expected to be produced. Okay, apply the Bayes theorem. Old machine produce 40%, new machines produce 60%. How we have done it? You can calculate it as we know the numbers. For old machines, 12,000 faulty parts were made out of a total of 80,000. Hence, old machine produced 15% faulty parts. Out of 80,000, 12,000 mean 15%. New machines produced 9,600 faulty parts out of a total production of 120,000, means faulty parts are 8%. So we have found the probabilities out of the data. Okay, first part of the Bayes theorem means we have faulty parts and good parts and old machine and new machine. We knew that old machines are producing 40% wrong parts, and new machines are producing 60% wrong parts. So, these are old machines, they are producing total parts. 40% parts are made by old machines and 60% parts are made by new machines. So, faulty parts are produced if machines are old, they are 15%. They have probability of 15%, and faulty parts, if machines are new, they have probability of 0.08%. And good parts are produced when the old machines are there, it is 0.85, and 0.92, they are the good parts produced if the machines are new. This is the data given to us. So we construct a prior and posterior table for probabilities. This is the old machine, the same example, and you can relate it as we have discussed it earlier. Okay, this is the solution of the problem. We have found the joint probabilities, again 0.15 multiplied by 0.4, 0.08 multiplied by 0.6, and similarly rest of the two. So we have found joint probabilities of faulty parts 0.06 and 0.048 for old and new machines, and good parts 0.34 and 0.552 for old and new machines. Marginal probabilities can be calculated by summing up both old and new machines faulty parts. They are 0.108 and 0.892%. So what are the posterior probabilities? So faulty parts are produced. Old machines have 0.556 and new machines 0.444. Similarly, good parts by old machine 0.381 and the new machines 0.619. So probability of total faulty parts are 0.108 and probability of good parts are 0.892 as we have calculated in marginal probabilities. So from this data we can calculate that from 400,000 parts it is expected that 400,000 multiplied by 0.108 probability of faulty parts means 43,400 faulty parts are expected to be produced. And out of faulty parts of 24,131 means 55.6% faulty parts will be produced by old machines only. So this is all from this part. We will be meeting in the next part.